Thanks for stopping by CSEC Biology TCP. We're going to be looking at the May-June 2014 Paper 2, Section A, Question 1, which looks pretty much at AIDS. The instructions are: answer all questions in this section, write your answers in the space provided in this booklet. Human immunodeficiency virus, HIV, is commonly transmitted via unprotected sex with an infected person. We are supposed to suggest two other ways by which HIV is transmitted. So we are looking at two other ways other than sexual intercourse. And there are many other ways. Blood transfusion from infected person, infected mother breastfeeding the baby, sharing needles with infected person, and of course a virus can of course cross the placenta to affect the fetus. So there we would have given you more than two, enough for you to get exam ready. The other question: acquired immunodeficiency syndrome, AIDS, is caused by the human immunodeficiency virus. This virus affects some cells of the circulatory system. Name the cell that is specifically targeted and destroyed by the human immunodeficiency virus. And this is going to of course be your T lymphocyte cells. That's the cell that the virus usually target, and of course having destroyed this cell, the immune system is usually weakened. State 2 signs and symptoms of AIDS. Now, the fact that when one is affected by AIDS, the immune system is compromised, it makes one susceptible to many other types of disease. Hence, a person suffering from AIDS may show signs and symptoms that are common to many other diseases. However, the common signs and symptoms here are rapid weight loss for AIDS and of course recurring fever. There's usually profuse night sweating. That is another big thing there for AIDS, as it were, for the signs and symptoms. Let us remind ourselves, however, that signs refer to those things that we can see or detect, while symptoms refer to that which the patient would have to tell us about, like I'm feeling dizzy or I'm having a pain here or there. That of course would have been examples of symptoms. Let us look at C. Both gonorrhea and syphilis are transmitted via unprotected sex with an infected person. Why are these diseases referred to as venereal and AIDS is not referred to as venereal? It might be said. Now, what I've come across in teaching this concept is that students understand non-venereal to mean not or the reverse of venereal. Now, it should not be interpreted as non meaning not in this particular case. Now, the thing about venereal diseases is that they are transmitted via sexual contact. The thing about non-venereal diseases, they can also be transmitted via sexual contact, but there are many other ways in which these diseases can be transmitted, as we would have seen with AIDS earlier when we looked at ways in which one could contract the disease. Now, the reason here why AIDS is not considered a venereal disease is because AIDS, and let me correct that for you, AIDS is not transmitted only by sexual contact. AIDS is also transmitted by other means. So that is pretty much the reason for AIDS not being classified as a venereal disease, but instead a non-venereal disease. So if a disease can be contracted via sexual intercourse or other method, then we are going to consider it to be a non-venereal disease. However, If it is only contracted via sexual means, then it's going to be venereal. And we come upon the section that most students are afraid of. It's the graph. Now the table shows the estimated prevalence of HIV and the death due to AIDS within the Caribbean at the end of 2009. Now the table here has a name, Table 1, estimated HIV prevalence and death due to AIDS in the Caribbean. So that is the name of the table, and we need to pay attention to that. Then we must also look at what is captured in the table. Now we have 3 columns here, and how many rows do we have? 1, 2, 3, 4, 5, 6, 7, 8 rows. Now at the top of all the column, there's what we refer to as the header row, and the header row is usually going horizontal and columns are going vertical. So the first column, the name of the first column is country. Name of the second column, persons living with HIV/AIDS. The name of the third column, deaths due to AIDS. Then we're seeing in the first column, country there, the different countries that were studied, and of course we're seeing the second column, the persons living with HIV and AIDS, and the numbers here vary, and so too is true for deaths due to AIDS. The number vary, and we're seeing it for all these countries. Now interestingly, we're supposed to represent this information on a grid. Now on the grid provided in figure 1, construct a bar graph of the number of deaths due to AIDS using the data in the table. Now it's very important here to note that what we are constructing is a bar graph and not a histogram. Now a bar graph, usually the bars are not touching each other. With the histogram, the bars are usually touching. Data that is represented on a histogram, it is usually possible to be represented with a line graph, but a bar graph tends to show isolated data. So there is no continuity between the data set, as it were, for a bar graph. Let's look at the first question here before we do that graph. Now, which country has the highest number of persons living with HIV? Now, how are we going to get that information? We are going to go right back to the table. We're heading back to the table, and we look at the data set here. This refers to the persons living with HIV as is named in the header. Now, so the highest number we're seeing here, we're seeing 5,007, which is pretty high, 3,200, which is pretty high, but 80 has that number that we're looking for, which is of course 12,000. So we would have documented that nicely on the lines here that 80 is that country with that high number. Now the other question, which country has the lowest number of death due to AIDS? And here we have Barbados, and that was very easy to get that information because it's stated here in the table. 12, 15 for the Bahamas, and of course 15 for Cuba, with 12 being the lowest number here, and that's for Barbados. So we could have found that information without any hassle just by looking at the table. Now another thing we need to look at here, which is rather interesting, the Bahamas and Cuba have almost similar number of persons living with HIV and AIDS. However, Cuba has 15 deaths while the Bahamas has 50 deaths due to AIDS. Now let us look at this figure between Cuba and the Bahamas. So we're looking at Cuba. Cuba has 660 persons living with AIDS. Cuba has 770. So the Bahamas 660, Cuba 710. And look at the death. For the Bahamas we have 50, and for Cuba 15. Now what would have caused this difference in the death toll despite the number of persons living with AIDS is somewhat similar? What do we think? It said that we're supposed to suggest one reason why Cuba has less deaths than the Bahamas. And we must take in consideration here, it is a suggestion. So your answer might be a little different than mine, and so to your classmate, once it is based in scientific facts and you can support that, I'm sure you could use it. So we're of the opinion that more persons in Cuba took the antiretroviral drugs than people in Bahamas or in the Bahamas. This resulted in less death for Cuba. Another thing that is also true is that Cuba tend to have one of the better healthcare system in the Caribbean. And we move on down to the graph, and the information that is on the graph is captured from the table. Now let us get back to the table just in a bit. To construct any graph, it is very important that you are able to understand what you put where on the graph. Now the line at the bottom here represents the x-axis, but the axis must be named. Now the information that is placed on the x-axis is usually the information that represents the independent variable. Now the independent variable in most cases will be reflected in the first column of your table. So this is the information here that we would have placed on the x-axis. However, the name for the x-axis was very easy because we took it from the table. The same information that is in the table, we can use the same name for the axis. However, on the other side, which is the y-axis where we are going to be putting this information, we use death due to AIDS for that side. So now that we have named the axis, death, this is for the y-axis and this is for the x-axis, then we need to represent the information on the graph. Now to represent the information on the graph, we must have a scale that is fitting for all the data set. So really there must be some consistency. Great. So to place the data on the x-axis or country, what we did, we used 1 centimeter in width to represent each country. So on the x-axis, 1 centimeter is equal to a country, right? So we got that there just for you to understand clearly how we got that bit in. Remember, this is a bar graph or a bar chart, so the graph, the columns here should not touch each other. If it were a histogram, then the columns of course would be touching, but in this case it is not, so the columns are not touching. So we need now to put this figure here on the y-axis, and this is where we have some challenges, as it were, with students not wanting to do the graph, because the data set here is in no geometric order or arithmetic order. There are some things that are really way out. Look at 15, 12, 50 versus 230 and 710. All that information must be captured on the graph. So then we must have a suitable scale that can capture all this information on the graph. Bearing in mind, we want to use at least 70 to 75% of that graph leaf to represent the data set. So here we have it, and you'll have to pay great attention to this type of graph. So what we did, we created a scale that should be able to capture everything. Now there are some figures that are really way out, and we're going to show you how we treated with that. So we're saying here by our scale that on the y-axis 1 centimeter represents 50 deaths. Now each of these bar here, these little cells, represent a centimeter. So if this here, this darker line represents 50, then we have some line between here. Each of these smaller line will represent 10, right? So we're going to have 10, 20, 30, 40, 50 on the darker line. So we know that for the Bahamas we had 50 deaths. Now here we have for Barbados, it is going a little over 10, right? So we remember from the table, for Barbados we had 12. So it is not so much in the middle. It's not so much in the middle here. It's just a little bit over the line that represents 10, while for Cuba, which has 15, it is a little higher, but it is still not touching the 20 line. It's somewhere midway between the 10 and the 20 line. So we're able to capture that, and it looks pretty close here, but that's fine for your exam. That'll be taken care in your mark scheme, And then we move on over to the Dominican Republic, and here we're having we said that we had 210, 20. Let us look at that. The Dominican Republic, we had 230. So definitely we want to pull this line up to 30. Let's get that out of the way. We want to get this blue line up to 30. So 30, of course, is going to be just a little tad more. 30. So that would have been 230 for the Dominican Republic. Alright, so that there is all sorted out. Great. So all we did was just to extend this bar here. I would have gotten 230. So this is 2, 10, 20, 30. Alright, great. And then we have 80. And 80 is an outlier with a really big number. Going back up, 80 has 710. Now, how do we represent 710 when our highest number so far is 230 and we really don't have that space on the graph leaf because this is a much smaller graph leaf that we're used to. Now, what we do, we use this symbol. This is one of the symbol that we can use. And what this means is that there's missing data, right? So it's as if we were supposed to fold the graph leaf under and some of the part of the scale here is hidden underneath. So we broke this line here using these two lines, and of course we could have started back at 700. Alright, so we would have missed out on data after we completed 300. We would have missed out on some data moving this. I think this would have been about 350, and then we lost some information and started back at 700. This is the acceptable symbol, or one of the acceptable symbol. There is another that I know. I don't know if there's more than two, but there's of course another that I can relate to. So here we would have gotten this 710 in nicely because we use the symbol. So you are required to know this symbol, whether you are going to be using the symbol or you will have to interpret a graph with the symbol. And then the other part of the graph is pretty much consistent. You can read the bars here and of course compare it to what is in the table. There we have 90 for Trinidad and Tobago and 120 for Jamaica. So let's look at that. 120 for Jamaica, and what was it for Trinidad and Tobago? Let's look at that. Trinidad and Tobago, it's 90. So if Trinidad and Tobago is 90, so then this here would have to come on back down to there. Alright, great. Alright, so we made our corrections here. So we have Trinidad and Tobago being 90 and Jamaica being 120, and all that we did was just to draw some bar. Remember, it's a bar graph, so the bars should not be touching each other. Now, important to note are some things that we need to capture on our graph. The name of the axis, country for the x-axis, and deaths due to AIDS for the y-axis. We had to work out a scale, and we had to put in the symbol in order for it to work. Now, we had to put in a scale here to show what each represents, and usually your graph will have a title. Now, the title that is supposed to be on your graph, you could use this here to say graph showing estimated HIV deaths due to AIDS in the Caribbean. So that is of course what you would call your graph, a title that you would have given to your graph showing the estimated death due to AIDS in the Caribbean. that is the title that you would have given to your graph, and probably you could write that title right where you have CSEC Biology, the cover page, or CSEC Biology TCP. So always remember to write your title in. Your title is going to be taken from the table, but you're going to modify the table name to make it suit what's on your graph. That's the only data we have in place here. But right where we have CSEC Biology TCP, you're going to be putting the information in. Now, please be reminded to like, share, and of course, subscribe to the channel. And remember, at any time, you can click that blue button below the video that says CSEC Biology TCP to access our many videos. When you subscribe, remember to click that notification bell and select all, so you'll be notified as soon as there is a new publication. Let's move on down to the other question. Now, this is a final question for this paper. The economy of some countries depend heavily on tourism. So just one effect that a high incidence of AIDS would have on these countries. Now, this could be argued many ways, so your point might be a little different than mine, but I do invite your suggestion or comment or view in the comments below respectfully. The country could lose out on revenue as tourists become afraid to visit the country and choose to spend their money in a more biosafe environment. So they want to go somewhere where they are safe, because there's a stigma around AIDS and HIV still. So persons who wouldn't want to come into an environment where they're not sure that their caregiver, the customer service rep, the team that will be working with them, they are ill. So persons might choose to spend their money in other locations where they are more comfortable, where they are safe, they are sure in some cases that they will be reaching back home safe. So that's our view there. Please be reminded, this is CSEC Biology TCP. Please join us on a Wednesday, Friday, and Sunday at 5:05 p.m. for live classes, and we're streaming from Kingston, Jamaica. Until next time, remember to study and be prepared for your exams.